So now we discussed about data retrieval. Let's put everything together, right? So we started with the data sharding concept. We know how to load the data. Now we discussed about how to retrieve the data. Let's put together everything into the picture, like how it's going to look like. Okay. So you have the data where you want to load the data into. So let's take this is a writer. So you want to take the data and load it into the writer database. So once you have the writer database, using a replication method, you can replicate the data to the reader as well as the another reader. In this case, we also treat it as a replicate. So where you want to put both readers connected to a web, so where the data retrieval can happen through the web. So the idea here is where you will be loading to the writers, the readers. So you are separating the readers and writer, where to minimize the load. So in this way, the data replication is happening through the native database replication method. So this is called a one cluster. So in sharding, one cluster consists of a reader and a writer and a replicant. The replicant can also act as a reader. So you want to connect both the replicant and the reader through via a web, so that the front lookup reflector can hit the web to get the data, right? So this consists of shard one single shard. Then you have a similar model where you are just basically same concept as a writer, replicant, and reader behind a web, and then this is called shard 2. So by doing this thing, what you are having is you have a complete redundancy failover scenario, where if the reader goes down, then your replicant will act as a reader, and if your writer goes down, this replicant also will act as a writer, where you can distribute the data. Then each shard is basically we can also bring up a geo-distributed cluster, where this shard is replicated to another geo-distributed cluster. You can also attach a GSLB on top of this one, where the data is the traffic is evenly distributed across the primary cluster and geo-distributed cluster. So let's put this GSLB in the picture. So what is the GSLB? So basically you want to take the cluster for a high availability, and also for the DR reasons, you want to distribute the cluster to a geo-located into a different geospace. So when you geo-distribute the cluster, you have a primary cluster, which is kind of have the shard 1, which we discussed about the previous diagram, the shard 1 and shard 2, and then you basically take the similar approach or a similar configuration, and then you geolocate the same cluster into a geo-distributed area. Here, there are a couple of ways you can keep this shard A in sync with the geo cluster. You can either use a native replication method, where you replicate the data from this particular shard A to the geo-distributed shard A. Okay, so shard B to geo-distributed shard B, or you can also do a dual load. So when from your loader, you can have a data loader here, where you can load the data, and also from here you can also load the data directly here. There are advantages of doing this, where so the advantage here is where you have full control over the data loading, and you are not waiting on the latency and over the replication. And then the disadvantage of doing that, if the data loading fails on the geo distributed cluster, then you have the inconsistency of the data. So you have to pick and choose based on your workstream process and what is the right approach to do. Either you want to use a database replication method, or you want to use the loader based data loading. In either case, we want to make sure that data consistency is maintained across the clusters. And then you have the GSLB approach, where it kind of distributes the data depending upon where the request is coming from. Then it will distribute the data to the respective cluster and retrieve the data back. So another advantage of doing this GSLB, for whatever reason this cluster goes down, still your application can redirect all the traffic to the geo-distributed cluster. It can retrieve the data back.